Hey there everyone, welcome back to another video. This is the second part of the series 06CHEM20. Okay, this chapter is about atoms, elements and compounds. Now it's quite a big chapter, so I'm going to be going over it really quickly. The first part needs us to describe the differences between elements, compounds and mixtures. Now basically, elements are atoms with the same number of protons. Now the key word here is the same number of protons, because what differentiates one element from another element is the number of protons within them. Then we need to know the difference between a compound and a mixture. Now a mixture is a combination of two or more elements not chemically combined. Whereas compounds are pure substances made up of two or more elements chemically combined. The difference between compounds and mixtures is that this is not chemically combined and this is chemically combined. Then describe the structure of the atom as a central nucleus containing neutrons and protons surrounded by electrons in shells. So what this basically means that the nucleus of an atom, let's say this is our nucleus. Now inside the nucleus you can only have protons and neutrons, and for the electrons they are there on the outside in what we call shells. So you have your electrons like this. This is basically what the structure of the atom is. Then state the relative charges and relative masses of a proton, neutron and an electron. Now okay, so basically let's say I have my particle here, the charge here, and then the mass here. So when you talk about a proton has a charge of +1 and a mass of 1, I think 1 EMU. Then electron has a charge of -1 but a mass of 1/1840. Now you can see that this is basically a very less, like a very small number, and that is actually the mass of the electron, which is why we say that most of the mass of the atom is concentrated inside its nucleus. Then you have your neutron, which has no charge and it's also AMU, but just write in your question paper when they ask 1. Okay, then define proton number as the number of protons in the nucleus of an atom. So we are going to define proton number as the number of protons in the nucleus of an atom, mass number or the nucleon number as the total number of protons and neutrons in the nucleus of an atom. So basically this is how it works. When you have an atom X, right, the number over here, the number here, and let me add the number here, this number is basically the proton number, which shows the number of protons in the atom. This is the nucleon or mass number. By the way, the proton number is also called the atomic number. This shows the number of protons and neutrons. So protons and neutrons, whereas Z just shows the number of protons. Now A is the charge. Okay, the charge could be positive, negative, but when there's no charge or there's charge of 0, that means that there's equal number of electron and proton. When the charge is negative, that means electron is greater than proton, and when it's positive, that means electron is less than proton. And only the electron can move from one atom to another. The proton remains the same. Then it asks us to determine the electronic configuration of elements and the ions with proton number from 1 to 20. Trust me, you can just go to Google and search for it and get the list printed and pasted on your wall. It's not really that difficult, so I'm not going to go into that. State that let me just choose a nice color. Okay, group 8 noble gases have a full outer shell. The number of outer shell electrons is equal to the group number in groups 1 to 7. The number of occupied electron shells is equal to the period number. Okay, Let's calm down and analyze this. They said group 8 noble gases have full outer shell. Now, if they have full outer shell, that means that they are stable elements, because they don't need to transfer or gain electrons in order to be stable. So they are highly unreactive. The number of outer shell electrons is equal to the group number in this thing. So let's say I have element X. It has one group shell and two group shell. Now this means that this is the group that it's going to be in. Okay, the number of electrons that are over here in the outer electron, my bad, is the group that it's going to be in. So if it has 1, 2, 3 and 4, this will be in group 4. Okay, then the number of electron shells that I have here, which is 1 and 2, is going to be the period number. So the period would rather be 2. Okay, then do I need to know anything else for supplement? No. Let's go on to isotopes then. Isotopes state that define isotope as different atoms of the same element. Different atoms of the same element. Now this is why many people make mistake. Most people write isotopes are different elements that have same number of protons but different number of neutrons. My friend, no, that's wrong. You have to state that they are indeed different atoms but of the same element with the same number of protons but different number of neutrons. That means I can have something like x3 and 5. This is completely not like, this is just something I made up, and x3 6. Now these two are isotopes of each other because they are the same element XX, same number of protons but different number of neutrons. It's the number of neutrons that affects the nucleon number over here. Okay, so 5 minus 3, which is 2. So I have 2 neutrons here. 6 minus 3, let me get that. Okay, just a second. Yeah, 6 minus 3, which is 3, is the number of neutrons over here. So they are the same element with the same proton number but different neutron numbers. Okay, so the same over here. I have for carbon and for chlorine. You can have different examples for different atoms. Now for extended, just a second. For extended folks, or the ones taking the supplement, you need to state the elements of the same okay, yes, this is also really important. Isotopes of the same element have the same chemical properties because they have the same number of electrons and therefore the same electronic configuration. You really need to remember this because they often ask questions on this. Calculate the relative atomic mass of an element from the relative masses and abundance of its isotopes. So now there's a formula for this that you need to know, which is AR equals to the percentage of the isotope times the mass of it plus the percentage of the second isotope times its mass all over 100. This is how you find the relative atomic mass, which is also denoted as AR sometimes. Then let's move on to the next thing. Now this is honestly a part which confuses me a lot of times. I usually get confused here, but I'm trying to learn it with you and make sure I remember what it is. Okay, describe 2.4. Yeah, correct. Describe the formation of positive ions known as cations and negative ions known as anions. Now when you go to electrolysis, this is something that you will definitely have to remember and do so many questions that you'll eventually remember this. So positive ions are called cations and negative ions are called anions. Right. State that an ionic bond, really important to know your definitions. Let me just get a nice color. State that an ionic bond is a strong electrostatic bond between oppositely charged ions. Okay, so let's say you have Na plus and Cl minus. You can see that they have different ions over here, right? But when you cross them and you form NaCl, this becomes an ionic compound. Describe the formation of ionic between elements, including the dot and cross diagram. Okay, now dot and cross diagram is not something that you really need to stress your life with. Basically, you first draw the structure of Na most of the time the question is going to ask you to draw only the outer layer of it. For example, let's say I have X, so I'll draw X, 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 and I'll draw X over here. Okay, I have X, and I have O. Let's say O. Just a second. I have O over here. Now, in order for this O and X to become stable, O will have to transfer its electron over here so that it will have a complete shell. Both of them will have a complete shell, so they will form this. Oops, sorry. Just a second. Yeah, so this will form X, and this will have this thing from here. Okay, and since it's gaining an electron, it will become, the charge will be -1, and I have O. So if O had a full shell before, so then it will become like this, and because it lost an electron, it becomes positively charged, so it will be plus over here. And this is basically how dot and cross works. Then remember, describe the lattice structure. Okay, describe the lattice structure of ionic compound as the regular arrangement of alternating positive and negative ions. So the giant lattice structure of ionic compounds is basically a regular arrangement of alternating positive and negative ions. So something I like to remember is like this. So you can see that they're regular arrangement of alternating. So first negative, then positive, then negative, then positive. So alternating positive and negative ions. Describe the formation of ionic bonds between ions of metallic and non-metallic elements, including the use of a dot and cross diagram. So basically we did a dot and cross diagram. Now ionic bonds are formed between non-metals and metals, like the bond between them is when you have a metal X and a non-metal Y, the bond that they form is what you call an ionic bond, because there is a transfer of electrons. Okay, explain in terms of structure and bonding the properties of ionic compounds. Okay, so this is basically, well, I don't think I did this. Well, we'll come to this. Okay, so it's basically the same. Okay, and the reason why they have high melting points and boiling points is due to the strong force of attraction between them, which requires more energy to break. And they are good electrical conductors when aqueous or molten, and poor when solid is because when it's solid, it has no mobile electrons or no free moving electrons to transfer the charge. Then you go on to simple molecules and covalent bonds. I think I'll cover this in the next video. So this chapter will have 2.1 and 2.2. So I guess I'll see you in the next video. Thank you for watching. Till then, ta-da.